When we do object-oriented development, we construct programs in terms of objects. In this video, I'm going to look at what those objects really are. To answer that question, I'm first going to ask the question, what is a program? And a program can be divided into two elements: data and control. The data are the pieces of information we're working on. We have different types of data, such as booleans, true and false, integers, 0, 1, 2, 3, 4, 5, -1, -2. We have floating point numbers that can be between 0 and 1, 0.3, 1.7, that kind of thing. We have characters, and we might even have strings of letters. We store our data in variables, and the variable will have a type, a name, and when we got a variable we can assign a value to it, and it will be recorded, and we can refer to it then using that name. So if I want to get the value from one variable into a new variable, I can refer to it using the name of that variable. The control part of our program are our instructions. They can be things like assigning a value to a variable, printing something out, or we have instructions that can choose what to do depending on a condition, such that if the value of a variable is one thing, then it can execute one instruction, otherwise it can execute another instruction. Most languages will provide us with mechanisms for structuring our data and our instructions. Again, we have mechanisms for abstracting data and other mechanisms for abstracting instructions. One of the simplest mechanisms for abstracting data is the array, where I can group together multiple elements of the same type and refer to them using a single name. So here I created a list of the integers 2, 4, 8 and 16, and if I want to assign one of those, either of those values, I can refer to the individual values using the name of the array A and an index into the array, such as 1, which will access the second element, 4, because the first element has index 0. So a single name and then the bracket notation for accessing either element of the array. In the C programming language we have a similar structure called the struct that allows us to do pretty much the same thing, but it allows us to group elements of different types into a single structure. So the way that works is we use the keyword struct. We name the struct. I'm going to call mine monster here. It's going to record values about a type of thing called monster. And then we're allowed to say what fields we want the monster to have. So I'm going to have a string, which is in C is a pointer to an array of characters. So it's going to have a string called description, or just desc for short. It's also going to have an integer to describe a location, and it's going to have a boolean, but we don't have a boolean in C, so that's just going to be another integer to indicate whether the monster is alive or not. So that defines a structure with 3 different data types inside it. Now this code only declares a type of a structure. It doesn't actually go and get us the memory or create a variable. To create a variable we have to give it its type, which is now going to be struct monster. I'm going to call the variable m, and then we can go away and assign values to the different fields. So we can say m equals, and here we have the same notation as we had for the array, a curly bracket, but note now that we have different values for each of the fields. So the first one is a string, the second one is the location, which I'm going to set to 2, and for the boolean I'm going to indicate that it is alive by using 1 to indicate true. So that is creating and instantiating the values of a monster structure. Now the way we use the monster structure when we have created it is by referring to the individual fields, and we can do that. Say I want to get the location out, so again I've got another variable and I want to set that equal to the location of my monster. So we have the monster variable and I want subfield location, and note here we introduce the dot notation. So dot location extracts the subfield, so we use the name of the variable and then a dot and then the name of the subfield of the structure. So this structure allows us to put multiple elements of data of different type in the same structure and to get at them by using the named subfields. The most common abstraction mechanism for instruction is the method, sometimes called a function or a procedure, but in Java we call it a method. The way we declare methods in Java is by giving it its return type, then a name. This one is going to be called desc world for describe world. It's not going to take any parameters, so I'm going to have an open set of round brackets and then an open curly bracket to get ready for taking the instructions that we are going to group together with this method. Now this method is going to check if the location is 0. It's going to print Brook else if it's not 0, then if it is 1, it's going to print field, and if it's none of those recognized ones, then it's just going to print that we're lost. And then we have the other closed curly bracket to indicate that that is the end of our method, and that those instructions within those curly brackets are the ones we want to group together and in the future referred to using the name desk world. Now the way we use that piece of code when we want to refer to it and call it from somewhere else is that within our code we have maybe some other instructions, and then we say, and now go and do all those instructions that I called disk world. And by doing that, just by using the name of the method, we can then call all those instructions we grouped under the name desk world. Now, in this context, objects are just another abstraction mechanism. What is unique about objects as an abstraction mechanism is that it allows us to group both data and instructions under one variable name, inside one type under one variable name. So let's see how that is done in Java. Much like when we declared the C struct, we have a keyword class replacing the keyword struct, but then we have the name of the new class, the new type. I'm going to call it world this time, and then we have an open bracket to indicate what the content of this type is going to be, and to our world class we're going to add some data, so it's going to have an integer variable, and that's going to be called player loc for the location of the player, and then we're going to have also a list of monsters. So a monster array just called ems. It's going to be too long. So there are two data fields in our world, two variables, pieces of data. Now what we're also allowed to do is to add methods, to add instructions. And we're going to have a method within this class. We're going to reuse the same method we had before, the void describe world method that takes no arguments. So we put a method definition within the class. I'm not going to put the instructions in now. Then we close the curly brackets for the method, and then we close the curly brackets for the whole class. Now this declaration has allowed us to define a data type, a class of type world that has both data, the two variables, and instructions, the desk world method within it. Something we couldn't do before we had the object mechanism. So how do we use this definition of a type? Well, we have only declared it so far, So one thing we want to do is we want to instantiate it. We want to create a variable that actually is of that type. So we do that much as we did before as well. We create a variable w of type world, and then we want to go away and grab the memory and instantiate it. And the way we do that in Java is with a new keyword. So new world, and that creates us a new object, a new instantiation of that data type called w. Now if we want to use that world, we can go and say, like we did with the struct, we can have another variable and we can assign the value of w's player location. So we notice the dot notation, just like from the structure, player loc, that will get the value of that variable. And after that we can go and ask the w object to execute the instructions within the desk world method, and note the same dot notation. W dot desk world will now go away and execute all the instructions we put inside the desk world method in the declaration. So here we have instantiated a new object, a new variable of type world, and we have accessed its player loc variable, and then we have called one of its method, all using the w dot notation to access both data and instructions within an object.